This is the second lab on systems programming. We'll be dealing with threads. We will not be doing so much concurrency because we are not trying to get them synchronized or working together to perform a task. But we will be looking at how students can create threads, get them started, at least see them printing, so you appreciate how threads are created. Okay, so the table of contents, what we'll be going through, I'll go through some sources, an overview, the types of software IDEs you're allowed to use. I don't care what IDE or compiler you use, any process that works for you. I'll talk about collaboration, and you should pay attention to the collaboration part. You are allowed to work with people, but I'll specify under what conditions. They are not allowed to code for you, but if you have an algorithm you want to work out with somebody, you can sit down, do a flowchart. I'm strongly recommending flowcharts for some of the more difficult parts of this exercise. So task 1 begins with simply saying create your Java classes, a producer, a consumer, and a manager. I'll go in depth into each, so no need to try and memorize everything I'm saying. I'll go through one by one, right? You have to show your definitions, your classes to the faculty, intern, or teaching staff. There will be 3 code samples. Code simple 1, simple 2, it means it's simple. 1 for your consumer, 1 for your producer, and another one where the 2, producer and consumer, are working together in the same piece of code. Right. And the code demo 0, 1, and 2, 1, 2, and 3, you will have to work on that outside class because I don't think people can finish that. So you would be showing only simplified code 1, simplified code 2, and simplified code 3 to the FI, right? So sources, this is a link I shared last week, and you're supposed to start going through learning about how threads work. It's the official tutorial from Oracle, and it's very, I should say, complete. It has all the details. If you take your time in this class, we'll only do about a quarter of it, and we'll try to brush you up on the other aspects. But if you're going to be a systems engineer, software developer, someone who deals with software, I would strongly encourage you go through that after the course is over. Make sure you understand everything that's going on, right? So anyone who takes operating systems, that should be capital O, capital S, I expect should understand what processes are, understand threads, and how we put the two together. Later in the course, we'll see locks, synchronization, and thread management. Right? And remember, you should have done the concurrency lesson. That's the link, and I repeat it. You will have it in the document. The IDE, you can pick any IDE that you want. I don't care whether you use NetBeans, Eclipse, or IntelliJ. Pick something that works for you. As far as collaboration, you are allowed to speak with others and discuss the algorithms in flowchart format. You can write it out in English if you want, but you are not allowed to code for each other. When coding, I encourage you to not simply try and code everything at once and say it doesn't work, it can't compile. Don't do that. I would say try and solve it in little pieces. You can even start with a simple hello world, and then you add a loop, and you add more loops, more variables, until you get it to work. But I think this is one of the classes where I will be introducing some problems that I know a lot of people can just write the code out at once. It's not something that someone can just sit you down and say do this and that. You have to think through, exercise your problem solving muscles. Yeah, just it's in your brain, exercise them. Right, so it's a mental exercise or a puzzle. Right, so if you are breaking down problems into simpler chunks, smaller chunks, you can simplify the problem a bit. Not a bit. That's bad. Okay, I may just leave that in. Now, the first task is to write 3 classes: producer, consumer, and manager. And those 3 classes, producer and consumer, should be runnables. So it says your producer, and this is the constructor, has a sleep method. Well, sleep, the 3 parameters go into the constructor: sleep, jobs to consume, total jobs to consume. I'll explain those shortly. And the producer has similarly sleep, jobs to produce, total jobs to produce. The idea for how I set this up is, and there's an example, is that in a lot of systems you have some things that are producing things and some things that are consuming things. So if you're at a cashier, maybe the cashier is producing receipts and the consumers or the clients are consuming the receipts. Or maybe you have a factory, someone is producing a raw material and someone is consuming the raw material. Or you have maybe economics, someone is producing a service and someone is consuming a service. So the idea of producer consumer actually runs through most of human life. It's somewhere. It's like I am producing lectures, you are consuming lectures. I am producing lessons, you are consuming lessons. It's there, it's everywhere. So in this case, I am providing three parameters. Sleep time in both producer and consumer means that the producer and consumer would sleep using thread.sleep. It's a method, you can look it up online, thread.sleep. And what it means is the producer or consumer, anytime it starts, it's going to sleep for a bit, wakes up, does some work, and then sleeps again. Now, there is jobs to produce, which is similar to what the consumer has, jobs to consume, and means that anytime it wakes up, it's going to try and do a certain amount of work. We are not actually doing work, we are just going to be printing messages to tell people we are doing work. We are not doing anything special. In later labs, we'll be doing things like printing to screen, handling web service requests, and so on. But for now, we're just saying, when you wake up, just print messages so it looks like you're doing work. This is just to make sure you understand. And we also have total jobs to produce, or in the case of a consumer, total jobs to consume. And what it means is every consumer has a lifeline. So you can think of it as a consumer would say, maybe I need 100 bricks or blocks, if you like, to build a house. And so it would say, well, I'll come by every week. The first week picks up 10, second week picks up 10. So there's this idea that it keeps coming and asking for things. The producer also has a limit for how much you produce before it exits the loop. And same thing, every time it wakes up, it produces a certain number of things. Now, when you write your classes, you don't have to implement all of these details now. You can't implement them now, but just show your class definitions to the FI. You can wait till the end to show it to the FI, but you must, before you leave, at least show him the simple 01, simple 02, and simple 03. So let's look at those, right? Simple 01, that's the first version of code. It doesn't have to be complex. All I want from you, so this is what will be in your public static void main. You call a method that's called run code simple 01. When called, this is the method. There's a consumer, and what the consumer does, this is the constructor. So that's, it sleeps for 10 seconds, 10 milliseconds. It's going to consume 2 items, and it's going to run for 7 cycles. But for the simple, do not try to use the 2. Just loop through and print 7 times. So 1/7, 2/7, 3/7. This is very simple. Everyone should be able to do this. And I'm also trying to get you to see how I'm formatting the output. So anytime it wakes up, so this is within the loop, anytime it wakes up, the first time it prints 1 sleeping, 1 awake. Consumer starting is all done within the consumer when it says run. Remember, every class that extends runnable has to implement the run method, and that means at the beginning of the run it says consumer starting, and before it ends it says consumer ending, and between the start and the end it loops a few times. First loop, second loop, third loop, and every time it prints a message. It's supposed to do this for your consumer. Show it to the FI, and also do it for the producer. And the producer now is doing 1023, meaning it's going to go through for 3 cycles. It would like to consume 2, but as I said, for the simple version of the code, do not try to consume 2 things at once. Just consume 1, 1, 1. Just print a message every time you go through the loop. 1, 2, 3. If you change the parameters, like if I make this 1000 to 10, I expect to see it would say progress 1/10, 10, 2 over 10, 3 over 10, and both you can show to the FI. Now, for the third one, which is more exciting, and so what I'm asking people to do is your run method has to have in the loop. So this is an example of my loop. I loop from 1 to a certain number, and every time I start, I print a message, consumer 1 sleeping. This actually has to be I, else it's not going to be looping through. I'm just using 1, so you can't just copy paste code. And what it's doing is every time it prints this, it sleeps, and it prints this. Your code will have to be more complex than this, because obviously if you look at this here, it's doing a little bit more than just saying sleeping, sleeping, sleeping. So I just gave a snippet. You can try and finish this up. Now, when you have, and look at this, it says run, and this is simple. Method number 3 creates a producer, creates a consumer, creates a thread with a producer, a thread with a consumer, and when it runs, it actually will interleave the result. So from beginning, it's running them at different speeds, and you can see consumer prints, producer prints, consumer prints, consumer, and you will not have it in the same order, but we expect that at the end of the day you have something similar to this, right? Now if you show, you can wait and show the FI this version, and if you can show this complex version, I'll assume it means you can create your class, you can get the first version working, second version working, but at least show him something before you leave, and try to make sure you can get this to work, right? Now, when you have left class, there is a complex version where I want you to handle the second parameter too, both the first and second. And what that would mean is whenever he wakes up, the consumer is going to try and print 2 messages. So this one, so look at this carefully. It says he's going to sleep every 10 milliseconds. Every time he wakes up, he's going to say he's used 2 items, and he's going to do it 7. He's going to use a total of 7 items. So watch, is still, he wakes up. So watch, he says manager is starting, consumer was sleeping, he wakes up, and when he wakes up, he consumes item 1 and item 2. Then he says, hey, I've made progress, it's 2 out of 7, goes to sleep. When he wakes up, consumes item 1, item 2. That means now he's up to 4 out of 7. He's sleeping, wakes up, item 1, item 2. He's gone up to 6 now. Sleeping, wakes up. And that means in total, 2, 2, 2, 1, that's 7. This is a slightly more complex output. It's going to require that you think about it. If you're having trouble thinking about it, try and do a flowchart. Think of the variables that you need to do this. Right. I think if you've done the first task, it's just a matter of looking at it and saying, hey, there's a pattern. Can you identify when you should print? I think this is should be something you can handle. And you're going to do the same for the producer. I kept this short at 2 and 3. But for the producer, note the method. He says producer, and I just call run. And what it does is to print. So when he wakes up, because it's doing 3 things, first time producer wakes up, says item 1, item 2. I have 2 over 3. Sleeps, wake up, item 1. Then he has 3 over 3. He then stops. The complex version is to have the producer and consumer, so thread for producer, thread for consumer, and it's now thread.start. Please note, whenever I'm doing threads, I say thread.start, right? And that means now they are running at the same time, and you can see the code is interleaving. So producer prints, consumer prints, and it's mixing, it's going through. But the interesting thing is, how do we know that the output was correct? What I did was I pasted into Excel the output and I sorted. Do the same to convince yourself it works. And when the output is sorted, you can see that the producer and consumer are doing exactly what they would have done if they were running alone. Consumer saying 3 out of 5, 5 out of 5, and remember it's because he was consuming 3 items at a go every time he woke up. And for the producer, it was producing 2 items, so 2 over 5, 4 over 5, 5 over 5. Very, I think, easy. There are some questions I would like you to answer at the end, such as the algorithm that I used. That's question 1. I want you to talk about it. the code, and you can write this out in Word. If you're using Word, you can print to PDF, I don't mind, or you can type it out in text, I don't mind. Either Word or text, something that most computers can use. Do not use an obscure format. Right, so what was the algorithm? Look at your code, and this is a systems design exercise asking you to compare the producer consumer. I ended up being able to refactor the code for producer consumer. They are doing very similar things. If you are, look at your code for producer consumer, the complex one, and ask yourself, can you simplify it? And I believe you can, because I was able to do it, and I believe you should be able to do it as well. Right, so what happens is I actually have an abstract class that both the producer and consumer extend, and when they extend it, they do certain amount of work in the abstract class. If you implement the abstract class, I'll give you 10% extra on this specific exercise. And the last one asks you to find out about producer consumer. Give 4 examples of some software or applications in computing that use producer consumer. And I also ask you, even if it's not computer science, 4 examples that have nothing to do with computer science but still use producer consumer. I used the cashier, you can't use that. I used making blocks and using blocks to build, you can't use that. So think of some examples on your own. Thank you for watching.